Hello everyone, my name is Yogesh, and in today's lecture I will be discussing about hierarchies in SQL Server. In particularly, I will be telling you about hierarchy ID data type, which introduced in SQL Server 2008, and still it is in the SQL Server 2012 and 2014 also. Now, starting with what is hierarchy. Now, hierarchy is just a normal tree-like structure which we sometimes we need to maintain into our SQL Server, and we usually make relational table to maintain this by making a self join. Now, in this example, what we have is we have this boss on the root level. Then boss has two child Ram and Ron, and Ram is having two more child Sahil and Mohit, and Ron is having one more child, that is Maze. So here what we have is we have this tree type structure which is getting in which we are maintaining with a simple relational table. Now currently there is a problem with relational table because it is very easy to maintain it, but integrity wise it is also good, but when it comes to getting the data back, it is not performance wise very good. And also we need to make complex recursive query to do the same task, which we can easily do through hierarchy ID data type. So more you will be getting clear about hierarchy ID when we will be coming back to our practical part. Now before starting with hierarchy ID, we need to cover some theoretical part also. Now in the existing table relational table structure, we must be having at least two columns, that is child ID and parent ID. Now child ID will be having some value, like boss will be having child ID 1, but parent ID it will be having null or something, null or 0. For other there will be some parent ID as well. So root will be having parent value ID as a null or 0, but other will be having some parent ID. So existingly we use this table structure to maintain our relational tables, relational values. Now when it comes to the hierarchy ID, now it makes a difference because hierarchy ID is just in data type and it will represent one column. So hierarchy ID is nothing other than a column which represents relational value in numerical format. Now how numerical format? Each node will be having information of its parent, or you can say parent, complete parent tree, and also the level information. Each node will be having you can say each node will be having its own information regarding its parents as well as its levels. And because it is just numeric representation of relational value, we can also implement DFS and BFS search over the hierarchy ID, which make it far better in performance when it comes to the recursive queries. Now the concept is very simple. When we have to make relational structure which shows parent child level hierarchy tree hierarchy, we can use hierarchy ID data type. Now we will see in while coming to the practical. Now before starting this, let me tell you what hierarchy ID do, and as well as what are the advantages of hierarchy ID. Now with hierarchy ID, you can convert recursive query into range queries. As hierarchy ID, as I told you, like it is a relational value in a numeric format, so it is a numeric format. So range queries can be implemented, are basically implemented to query the hierarchy IDs, and which make it far more performance wise better. Now after this we can use DFS and BFS can search over the hierarchy ID columns. I will tell you how to implement it later, and I will tell you what is BFS and DFS in the next lecture. Basically I have divided this lecture in two parts. One will be the introduction about the functions, as well as the little bit practical about hierarchy ID, so that you can brush up with the hierarchy ID, and later I will be telling you the advanced things. Now after this we also there is one more thing. All the methods which we will be using on hierarchy ID are .NET methods. So there will be advantage because there will is some .NET you can say query processing also available. So it is mixed, and also it is very better to use hierarchy ID. Now hierarchy ID, as I told you, it is in, like numeric value, so it is a scalar column and is sequence and number of var binary values. Now as I told you, each column will be having the value of the tree whatever it is following. So those tree value are also like binary values. So combining, there are sequence of values having the parent tree as well as itself. So it is hierarchy IDs will be stored in the var binary format. Now there is one thing to note down: range query are far better in performance compared to the recursive query, and we will see in the coming lectures. Okay. Now there is one issue with hierarchy ID. In the relational table we don't have to care about integrity because foreign key constraint is there, but in the hierarchy ID it automatically by default it doesn't maintain its integrity. We have to think and we have to make some things like some triggers and all to maintain the integrity, and it is not a big issue. I will tell you how to create, and even I will give you an example how to create the trigger, and it is very easy. Okay, now coming to this lecture content, as I told you, I have divided this lecture into two parts. Today in this lecture I will be covering this introduction and as well as use of these all functions. So these are the functions related to the hierarchy ID, and which will make your hierarchy ID implementation very easy and maintenance also. After this I will be telling you how to convert existing hierarchical ID like existing relational structure with having the implementation of hierarchy ID in it, and also to create two indexes which will implement DFS as well as BFS whenever it is required. And after this we will creating a trigger which will maintain the integrity. So these three topics will be in the next lecture, next video. So in this video I will be telling you about these topics. Okay, now coming to the next slide. Now as I told you, this is the example which we will be working on, like boss is there, then Ram, Ron, and the Sahil, Mohit, and Maze. And also as I told you, hierarchy ID, each node will be having their own information as well as their parent information also. As from the Mohit you can see, Mohit is a son of Ram, and Ram is son of Bose, that is root, and Maze is a son of Ron, and Ron is son of Boss, and this is also root. And also if in this format it is difficult to remember what is the like range. So what I did is we change it with the numerical value. So slash will represent the root, and here I can see like 1 is the child of 2, that is 2 represent the Ron, and slash represent the root. And same for the Mohit, 2 represent the second child of Ram, and and then slash represent the boss. So each node is having its parent hierarchy with it, if you see. So this is how hierarchy ID make it more easy to navigate through everything. Okay, now coming to these functions. Now before starting this function, let us jump up to the practical part, that is how does hierarchy ID works. Okay, now if you see, just hierarchy ID is just a simple data type having some value, and I have this value initialized, and if I try to execute it, it execute without error. Now suppose if I just remove this slash, and if I try to execute it now, it will give me an exception, because there is a particular format of hierarchy ID. Either it should be just a slash so that it can represent a root, or the value should be surrounded by slash as a JSON format so that it can represent this is the hierarchy ID. Now if I try to execute, it will get it executed. Now if I try to get it back, and you see this is getting us the value in a binary format instead of getting the value in which we have saved that like in which we have initialized this variable. So there is a difference. For initializing we are just using these values, we can use this binary format also, and as well as these values are used when we are trying to get, it is getting us in a var binary format. So we can convert back and forth according to our requirement. Now if I try to execute this, so here what I'm getting is, I'm getting the hierarchy ID whatever I have initialized in the format which is var binary. Then I'm trying to convert that to the string format using toString method. This is .NET assembly method, and then I'm trying to cast it as varchar. And if I try to execute it, I get three output. One is binary format, which is, as I told you, which is by default it will represent as var binary. Then I'm trying to convert it to the string using toString method, and same I am casting it to string using this cast method, and these two give me the same result set. So this is for just one information, like you can convert it by toString also, and you can cast it through this cast method also. Now with this you can see, like you can cast the binary into the format in which you have initialized the hierarchy ID. Now there is one more thing, we do have a method named GetAncestor. Now GetAncestor method will return us the nth ancestor of the current node. Now if I go back to the diagram, okay, now if I tell you the Mohit is ancestor is Ram, and Ram ancestor is Bose. So if Mohit is having the information about its all ancestors, so we can get all the ancestors using just passing by this method, that GetAncestor, and just by passing the number of ancestor which we want to get. So as I told you, like Mohit, like in this example we have three things. In this one we do have two parent above, like 1 and root. Now in this example I have 3 as a current node, Now the first ancestor will be 2, so it will be represented by /1/2. Now if I talk about the second ancestor, it will be just giving us /1, and if I talk about the third ancestor, it will give me the root because the last ancestor is root, and if I try to get the fourth ancestor, it will give me null because there is no fourth ancestor for this hierarchy ID. So if I try to execute and try to get ancestor at first ancestor, the second, then third, and then fourth, and I try to execute, I will get the values. Now here this is the current value of my node, whatever I inputted. Then I have the first ancestor, that is 1/2, because this total make one node. After this, if I get the second ancestor, which is my grandparent, it will give me /1, and after the third, it will give me slash, and no parent is there on the fourth ancestor. So this is how you can easily get the ancestor. Now from this simple method, you can see in the old scenario, if you have to get your grandparent and the grand to grandparent, you have to make recursive queries. So there was no other way to solve this situation. Now here you can solve it by simple doing this one. Okay, now there is one more thing. Now what I'm doing is I'm just converting. I have the CTE, which will be getting me the value whatever I have in the diagram, that is this one. So I will be converting that into the temporary table, and if I try to execute, okay, now if I just try to execute and see what I get. So here I have this boss is on the slash level, Ram and Ron at 1 and 2, and then Sahil and Mohit are the child of Ram, and then Maze is the child of Ron. So this is what I have this. Now as I told you, like each node will be having information about its parents. So from the node, like from the hierarchy ID, if they can get the information of the parents, as well they can get information about their level also. So there are two functions, get root, which on each level, if I want to get any like my root, I can just query this get root method. After that, if I want to get the level, I just have to tell node dot get level, the hierarchy ID column dot get level, to get my level of my values. Okay, if I try to execute, now it is telling me boss at the level 0, because boss is on the top. After then, Ram and Ron are on the same level, 1 and 2, according to our diagram also. After then, we do have my like other child on the second level. Sahil and Mohit are under Ram, and Maze is under Ron. So if I add one more value to this, now this is what I have one more to add. Now I add Dawn to the child of Mohit, means Ram will be having Mohit, and Mohit will be having one more child, that is Dawn, sorry. If I try to execute it, and if I try to get now I do have one more child here. Okay, now if I'm trying to get the level of all of these node again, I do have this one, like boss is at level 0, Ram and Ron are on the same level 1, and Sahil, Mohit and Maze are on same level, and Dawn is on next level, which is under Mohit. So this is how each node can get their information by just simply calling this method. I am just ordering this by get level, so that I can order them by level also. So how this can be easily made, you can understand from this sequence. Now there is one more method, like IsDescendantOf. Now this method is used to get any node, and as well as all the child of that node, like descendant of that node. Now there is a thing, is descendant of, if you see the definition, like from the word, it will meant like it is getting the descendant of that node, but instead it will be also getting descendant as well as that node itself. Okay, now if I'm trying to get my descendant of any node, okay, now let me remove this first so that it can make easy. What I'm saying is I am initializing my node with 1, means I'm initializing it with Ram, and I want to get Ram, Sahil, Mohit and the Dawn also, because as we know, Dawn is added under Mohit, so it is indirectly the child of Ram. So if I try to execute it, so if you see Ram, Sahil, Mohit and Dawn, I am getting all the childs. So so here how did I get? I just initialized like variable node which is of hierarchy ID with /1, and I'm saying I want to get all the records from the temp table where chain dot IsDescendantOf at node, like that is 1 is equal to 1, like means this method will return 1 and 0 if any node is matching up with this criteria, like where the parent or itself the node is 1, it should return me the record. So this is getting me the data. Now there is one more problem. If you don't want to get the node itself, so what you can do is you can say and chain not equal to at the node. So what it will do is it will get all the descendant except itself. Okay, so if I execute it again and I want to see, now I'm getting Sahil, Mohit and Dawn. Now you see, like Sahil and Mohit are on the second level and Dawn is on the third level. So what if you just want to get next level values only? You just want to get all the childs on next level, instead getting this child to subchild, okay, subchild to child. So you don't want to get, you just want to get child or at the next level. So this is how you can easily do, where you can say chain dot get level equal to at the rate node dot get level plus 1. Now node level will be 1 and plus 1 will be 2, so I am only getting the child where the level is 2. Okay, I just forgot to get the parenthesis, sorry. So I'm getting only the child of the next level. Now with this you can see how you can play up with the different functions. Now is descendant of, I think it is clear. It will be getting me the return all the nodes where parent will be the whatever the parameter we have passed, and the parent itself it will return. So okay, now coming to the next method, that is get descendant. Now this method is used to generate new hierarchy IDs. It will not return me any node, it will return me the hierarchy ID. Now if I see this example, if I want to let me comment it out. Now in this example, I have this left and right node. I want to generate new node between these two. Now I am saying like I just want to generate, okay, now let me change it at the rate left node slash at the rate right node. Okay, now I am saying I want to generate a new hierarchy ID between 2 1 and 2 2. So if I try to execute it and I run it, it will okay, let me translate that to string also. Okay, okay, now what it is, it generate a new hierarchy ID that is 2 1.1 and which lies it between 1 and 1 and 2. So what if I just change it to 1.1? It will generate me new hierarchy ID between 1.0. and what if I just change it to 1.0? Now it will generate me one more ID, so 1.-1. So it is just not about like it is generating a number, it is generating any random number which will match up as a new hierarchy ID between left and right. So what if I just don't want to generate left and right, I just want to generate any one maximum than anything. So what I will say, maximum of right node, and after this the second limit I am giving as null. So I want anything between maximum node and null, it will give me 2/3. So it is getting me the next node. Okay, if I don't want any like in decimal number on or something like that, or if I just want to make it vice versa, so I am saying this null this side and I am saying minimum of at the rate left node. So it will generate me new hierarchy ID. Now this hierarchy ID I can use to generate me the next hierarchy ID for my next node. So what if I just want to generate at the rate right node and null, and I will say I want to insert a new record, that is more, and I want to generate at more. So I just want to generate a next record, this is more, and I want to insert that into my table. Insert into stamp. If I try to execute, I am able to get, and if I am trying to execute it again, so here I am able to generate one more record for more, and which is the child of Ron. Now Ron is having two child, one will be the maze, and second will be this more. So I am able to generate a new hierarchy ID, and with that I am able to insert I'm able to insert a new record with new hierarchy ID also. So with this get descendant, you can generate new hierarchy ID randomly. Now coming to the last method, that is get reparented value. Now in this, suppose if you have this structure, now suppose you want to move Ram under Ron. So you will not be updating all the values, you will not be calculating all the values. So there must be a way with which you can automatically calculate the values. So there is a method named get reparented value. Now with this we can regenerate hierarchy ID for this node if you want to move it under some other parent. Also it will recalculate the value of all the subnodes under it. Okay, now how to get subnodes? As we know, like with IsDescendantOf method, if we pass the node value, it will get me the node itself as well as its subchild. So now I want to generate new ID. So for this I need one old ID and one new ID. As I know, I just inserted the my new record, that is 2/2, which is more. So my next ID will be 2/3. So I know my next ID will be 2/3. So I am manually using it. I am saying my next node value will be 2/3 and my old node value is 1, that is Ram, and I want to generate new nodes 2/3 and sub node according to that. So I will be just executing this script. So it will be getting me. So now as I told you, like Ram will be replaced by 2/3. So for every other node where this it was like /1 in the beginning, it will replace it with /2/3, because Ram is now initialized with the new ID and it executed on the subchilds also. So with this I can use it and update the values in the existing table also. Now you can see like how easy it is through hierarchy ID to generate new ID, to reinitialize with the new ID if there is a change in tree structure, which was not at all very easy with the recursive queries. Now as you can see, now these methods provide you a greater flexibility compared to the recursive queries, where you have to think of a logic, develop a logic, and to do operation over it. So with this hierarchy ID you can directly generate, you can directly execute and directly get the level, ancestor, descendant of, get new hierarchy ID generated with simple these methods. So this is how hierarchy ID makes your life easy comparatively to the relational table. So in this lecture, as I told you, like in the next lecture I will be telling you now in the next lecture our content will be the converting the existing table, relational table, to the hierarchy ID implementation, and also the indexes which will help us into DFS and BFS, and also I will be telling you what is DFS and BFS. And other than that, I will be creating a trigger. I will be telling you how to create a trigger to maintain the integrity. So this is all about hierarchy ID for now as an introduction. Now if you have any question, you can contact me through my email ID, that is yogesh.mail@gmail.com. You can get the content from my website, the script and all, on the textfire.in, and also my phone number is this. You can directly contact me on my phone also, and this is my Skype ID. So feel free to ask any question, and also feel free to do comments on my channel, and please do subscribe. And also if you have any issue, I do take personal lectures also. If you need some help, I will be happy to help you. So keep learning, stay healthy, and enjoy.